here's perfect problem 3 for Math 95. We're given a function, f of x equals x minus 3 over x plus 2, and asked to find f of 8. The way you find f of 8 is you think about it like putting 8 into your function. So you place all the x's in this expression with 8's. So you get 8 minus 3 instead of x minus 3, and 8 plus 2 instead of x plus 2. And since 8 minus 3 is 5, and 8 plus 2 is 10, and that reduces to 1/2, our final answer is just 1/2. Find a value of x so that f of x equals -2. So now we're kind of going backwards. What we're saying is, what would we have to put into this machine so that -2 would come out of it? In other words, solve this equation for x. We can do that. We can multiply both sides by x plus 2 and get x minus 3 equals -2 times, show all my steps, x plus 2. So x minus 3 equals -2x minus 4. If you add 2x to both sides of the equation, you get 3x, and add 3 to both sides of the equation, you get -1. So your final answer is x equals -1/3. I don't think you have to, but if you really felt compelled to check your answer, what you could do is figure out what is f of -1/3. And if we did everything right, f of -1/3 should be -2. So f of -1/3 is you put -1/3 into this expression, -1/3 minus 3 divided by -1/3 plus 2. 3 is 9/3, so -1 minus 9 is -10/3. And 2 is 6/3, so -1 plus 6 is 5/3. And I'm kind of running out of room here, but if I divide these fractions by multiplying by the reciprocal, cancel out the 3's, I get -10 over 5, which in fact is -2. So I don't know that you have to check all this right here, but you can if you really feel like it. Alright, question C. Is 0 in the domain of f of x? Okay, so what the domain of f of x is all numbers that you can put into this function and have something come out of it. So the way you check that is, maybe this is the same, this is equivalent to asking, does f of 0 exist? And in fact it does. F of 0 is you just replace all the x's in this expression with the 0. So instead of x minus 3, we get 0 minus 3. Instead of x plus 2, you get 0 plus 2. And so we get f of 0 is -3/2. -3/2 is a number. It exists. Maybe. So yes, it does. Yes, it is. Is 0 in the domain? Yes, it is. Alright, I guess that's a good enough explanation. Find the domain of f of x and express your answer in both interval and set builder notation. Alright, so the domain of f of x is all the numbers that you can put into f of x. So we figured out that 0 is in there, but the question is what else is in there? So our domain, there's kind of two domain rules. For this class, there's going to be a third in another class, but for now, we just have to make sure we don't divide by 0. And we don't take the square root, really any even root, don't take square root of a negative number. What's kind of nice is this function doesn't have any square roots going on in it, so all we have to worry about is dividing by 0. We just have to make sure x plus 2 does not equal 0. In other words, we just have to make sure that x is not equal to -2. So the domain is all numbers out there except for -2. And the way you write that in interval notation is you say everything from -infinity up to -2, union everything from -2 up to infinity. This is everything less than -2, this is everything bigger than -2. And in set builder notation, you say it's the set of all x such that x does not equal -2. So there's two ways to write the same thing, our domain of f of x, which is everything except for -2. Finally, is 0 in the range of f of x? Why or why not? Range is kind of tricky, but the idea there is they're asking, is there a 0 so that x minus 3 divided by x plus 2 equals 0? Is there an x so that when you put that x in, 0 comes out? It turns out there is. You could solve this. Multiply both sides by x plus 2 and you get x minus 3 equals 0. Add 3 to both sides and you get x equals 3. So that this question mark, and we do some work here and say, yes, it is, because f of 3 equals 0. So since 0 can come out of this function, 0 is in the range of f of x. And that is the end of this quiz.